OSPF version 3. In this video, we are talking about the OSPF version 3 and also the fundamentals of the OSPF version 3, and finally OSPF version 3 basic configuration and also verification. You know that OSPF version 3 initially was developed for the IPv6 routing, but in next version of the OSPF version 3, we have this capability for routing both IPv4 and also IPv6 address family. Let me to show you. Look at here. This is the history of the versions of the OSPF. As I mentioned before, OSPF version 1, okay, was the first version, and you know that the OSPF version 1 now is expired and we cannot use it. After that, OSPF version 2 is using for IPv4 routing, and we have learned about the OSPF version 2 in previous videos until now. Okay, after that, in the first implementation of the OSPF version 3, okay, we had this capability of IPv6 routing. But in the next generation of the OSPF version 3, we have the capability of the IPv6 routing and also IPv4 routing. Both address family, okay, can be routed with the OSPF version 3, and we are talking about this version in this class. Actually, the first version of the OSPF version 3, okay, should not use in today's networks, because in most cases we are migrating from the IPv4 to IPv6, and we need both IPv4 routing and both IPv6 and also IPv6 routing. Because of that, we should use only this method. Okay, I will talk about the detail of OSPF version 3, but let me to say that previously, when you want to configure the OSPF version 3, the first generation, we should configure IPv6 router OSPF process ID. Okay, and you know that for the IPv4 OSPF or the OSPF version 2, we are using router OSPF PID. But in the next generation, in the generation of the OSPF version 3 that we are using it now, we should use this command for starting the process: router OSPFv3, for example, PID. Here you can see the difference between the configuration of these three methods. Actually, in this class about the OSPF version 3, we are using only this method, router OSPFv3 PID, and we don't use this method because with this method actually you are enabling OSPF version 3 only for IPv6. But with the next generation of OSPFv3, we have the ability of routing for both address family of IPv4 and also address family of IPv6. Also, let me to emphasize that we have many similarities between the OSPF version 3 and OSPF version 2. Actually, about some of the fundamental rules, OSPF version 3 and OSPF version 2 are similar with each other. But we can say also we have some differences. In this class, I'm going to talk about the similarities and also the differences between the OSPF version 2 and OSPF version 3. But I can say that the main functionality of OSPF v2 and OSPF v3 are same. Actually, we have more similarities in compared with the differences between the OSPF version 2 and OSPF version 3. Because of that, in the first video of OSPF version 3, I am trying to show you the basic configuration, and after that I want to talk about some of the similarities. Step by step we will learn about the differences between the OSPF version 2 and OSPF version 3. You know that for OSPF version 2, okay, we have used the router OSPF process ID, but here now we should use router OSPF v3 process ID. Let me to configure one simple scenario. After that, we can talk about the more detail of OSPF v3. Here, as you can see, we have a simple scenario, include three areas: area quad 0, area 0001, and area 0002. You know that the main functionality of the OSPF v2 and v3 are same. This means that for example, why we are using the area structure, because of reducing the resource usage, and also some other benefits that you have learned in the OSPFv2. Again, here we have all of these benefits. Because of that, you know about the OSPFv3's basic function, but now we are trying to learn about the configuration, verification, and step by step about the detail of the OSPF version 3. But you know that for starting each of routing protocols in the IPv6 world, the first command is IPv6 unicast routing. You know that by default on the routers, okay, we don't have the capability of routing of IPv6. Because of that, we should enable it with IPv6 unicast routing. This is not the command of the, for example, OSPFv3. This is the command of enabling routing or IPv6 unicast routing in for all of the methods of the routing. After that, we should use router OSPFv3 process ID, the first command, as I have explained before. And after that, if you want, this is optional, you can configure address family IPv4 or IPv6 unicast. If you don't configure this command, okay, OSPF automatically, when we are configuring OSPFv3 on one interface, is enabling this address family. But if you want, you can configure it. Address family IPv4 unicast, this is address family identifier, this is sub address family identifier, means unicast or multicast. Address family IPv4 unicast, address family IPv6 unicast. Here in this scenario, we are using only the IPv6 routing, but if you want, you can configure IPv4 routing. Also, in OSPFv3, we have the concept of router ID exactly with the same concept and same method of selection as the IPv4. Router ID, okay, is the identifier of one router in OSPF version 2 and also OSPFv3, and in both of them, router ID is selecting, is choosing with a same method. You know that router ID has 32-bit, okay, and we are writing the router ID in dotted decimal notation, ABCD. This is like the IPv4 address, but you know that this is not actually the IP, okay. You can use any value between quad 0 or to quad 255 for the router ID, but some of them cannot be, for example, used for OSPF. For example, if you configure quad 0, if you use the quad 0 as the router ID, the OSPF doesn't establish neighborship, okay? But if you want, you can configure the router ID uniquely. The only things that it is important in router ID selection is the uniqueness. We should select the router ID with unique value. The configuration of router ID is so easy. Here you can see the command of router ID ABCD. You can configure this command under the address family IPv4 or under the address family IPv6, or if you don't configure address family command, because this is optional, you can configure under the router OSPF process ID. Means for all of the address family, we are using this router ID. Okay, actually we can say about the router ID, the first priority is the manual configuration of the router ID. If you don't configure the router ID, and if we have one loopback interface with IPv4 address, okay, the highest IP address, okay, of loopback interfaces, okay, is the router ID. And if we don't have any loopback interface, the highest IP address of non-loopback interface is the router ID of the, for example, router. But as you can see here, this is exactly same with the OSPF version 2, highest IP address of the non-loopback interface. You know that this is possible that we don't have any loopback interface or any non-loopback interface with IPv4 address, okay? Because of that, you should configure the router ID in OSPF version 3. It is recommended to configuring the router ID in the OSPF version 3, but if you have IPv4, this is not mandatory. Okay, because of that, in most cases, we are configuring the router ID in the OSPF v3 with the command router ID ABCD. Okay, actually here now we have the OSPF v3 process. Then you should go to each interface and using this command interface name, OSPFv3 process ID, IPv4 or IPv6 area ID. This is like the interface specific configuration of the OSPF version 2. Let me to show you one example. Here we have this scenario. I will configure this scenario, but for now let me to show you only one simple example for router 1 configuration. Look at here, we should use IPv6 unicast routing. The configuration is so easy, okay? And then we should use router OSPFv3 process ID, for example, is 1, and then router ID quad 1. Here this is mandatory to configuring the router ID. Why? Because as you can see, we don't have any IPv4 address. Because of that, we should configure the router ID. After that, here we have one interface ETH00. On this interface, we can configure OSPFv3, then process ID 1, IPv6, okay? And after that, area, for example, 0001. That's it. Everything is similar with the interface specific configuration in OSPF version 2. IP OSPF replaced with the OSPF 1. Then we have process ID. Also, we have one term IPv4 or IPv6, and then area ID. Okay, this is so simple. Let me to configure this scenario step by step. After that, we can understand more than now about the for example, OSPFv3 configuration and also verification. First, we should configure this scenario about the IP addressing. This is the R1. Here we have this configuration enconft, and then we have host name, as the host name is R1. After that, interface, okay, ETH00. IPv6 address of this interface is 2001 db8. As you can see, we are using this syntax 2001 db8, then the router number of the, for example, left router and the router number of right router. Actually, I'm using the lower number in the left and a higher number in the right. That's it. IPv6 address 2001 db8 12:1/64. And after that, no shutdown. This is the command that we need for the IP addressing in the router 1. In the router 2, let me to copy this configuration, R1 configuration, then R2 configuration. Okay, host name is the R2. Interface ETH00's IP address is 2001 db8 12:2/64, and then no shutdown. After that, let me to configure the interface ETH01, this interface, IPv6 address 2001 db8 to 3:2/64. And after that, let me to configure the router 3. We can copy the configuration of the router 2, and this is the configuration of the router 3. Okay, here host name is router 3, interface ETH00, IPv6 address 2001 db8. Okay, about the router 3, 2, then 3:3/64, and no shutdown. About the ETH01, IPv6 address 2001 db8 3, okay, 4:3/64, and then no shutdown. After that, the router 4. This is the R3's configuration, and this is the R4 configuration. Host name is R4, interface ETH00's IP address is 2001 db8 3, then 4:4/64, and then no shutdown. After that, interface ETH01, this interface, IPv6 address 2001 db8 4, 5:4/64, and then no shutdown. And finally, the router 5. Let me to copy the configuration of R4. This is the R5 configuration. Host name is the R5, and interface ETH00's IP address, IPv6 address is 2001 db8, okay, 4:5:5/64. This is the first part of our configuration. Now let me to configure the OSPF starting from the router 1. Look at here, starting from the router 1. It is so easy. Router OSPF, okay, router OSPFv3 1. That's it. Okay, here if you want, you can configure the address family IPv4 unicast, IPv6 unicast, or if you want, you can ignore it. But before the router OSPF version 1, we should use IPv6 unicast routing. Okay, unicast, then routing. Here I'm going to directly configure the router ID. Router ID is a quad 1. Okay, and then we should go to the interface, for example, interface ETH00, And after that, here we need this command OSPFv3, okay? After that, the process ID is 1 and then IPv6 because we are routing IPv6 now. And then here we should use area, the area ID. Area ID is 0.0.0.1. That's it. This is the configuration of the router 1. Let me to show you this the result of this configuration. After that, we can continue with the router 2. This is the R1 CLI. And here, first, I'm going to copy the IP addressing. Okay, look at here. This is the IP addressing of the router 1. Here, assume that we are trying to enable router OSPFv3 1. Look at here, router OSPFv3 1 can show us this command to us. IPv6 routing not enabled. This means that if you don't enable the IPv6 unicast routing, okay, you cannot configure any routing protocol. Because of that, we need to configure IPv6 unicast routing. Look at here, IPv6 unicast routing. Okay, unicast routing, and then you can configure router OSPFv3, for example, process ID. Here, if you want, you can use address family IPv6 unicast, okay, and then configuring the router ID. But if you want, you can configure here the router ID quad 1. This router ID is the router ID of both IPv4 and IPv6 address family. Okay, after that, we should go to the interface ETH00, interface ETH00, OSPFv3 1, then IPv6, then area, after that 0.0.1. That's it, 0.0.0.1. That's it. Now, let me to configure the router 2. This is the router 2. I'm going to configure only OSPF, okay? Here we can use IPv6 unicast, then routing. You know that the router 2 is ABR, the same concept. After that, here we can configure the router, okay? OSPFv3, for example, 1. Here we can use the router ID as quad 2. After that, we should go to the interface ETH00, okay, interface ETH00, and here we need to use this command OSPFv3 1 IPv6 area. After that, about the ETH00, this interface is residing in area 10001. That's it. After that, interface ETH01 OSPFv3 again 1 IPv6 area quad 0. Quad 0 is the backbone area. Everything is same, okay? And let me to copy this configuration to the router 2 CLI. This is the router 2 CLI. And you know that after some second, we will see the neighborship between the router 1 and router 2. But here, because we have ETH link, we will have DR and BDR. Look at here. Everything is correct. I will show you the command of the verification of the OSPF and we will use it. Don't worry. Let me to configure the next router, the router 3. Router 3 is a backbone router. The same concept again. Here we have IPv6 unicast routing, the first command. After that, router OSPFv3 process ID is 1, and then router ID is quad 3, okay, and then interface ETH00 OSPFv3 1 IPv6 area, then area ID. Area ID is quad 0, and also on the ETH01 we need to configure same command interface ETH01 OSPFv3. Okay, OSPFv3, then 1 IPv6 area quad 0. That's it. This is the configuration of the router 3. Let me to copy it. And then we can paste it on the router 3 CLI. This is router 3 CLI. So easy. Now let me to configure the router 4. This is the router 4. Look at here. In the router 4, we need to configure similar commands. Okay, starting from the router 4 here, IPv6 again unicast routing, the first command, then router OSPFv3 1, then router ID, okay, quad 4, this is ABR, and then interface here over the ETH00 we should configure OSPFv3, then process ID 1 IPv6 area quad 0, the first command, the first interface, then interface ETH01, and after that OSPFv3 1 IPv6 area 0.0.0.2. That's it. This is the configuration of the router 4. Let me to copy this configuration and pasting on the R4 CLI. Okay, the next router is the router 5. Let me to configuring the router 5 also here. The first command IPv6, again unicast routing, then router OSPFv3 1. After that, here we can use router ID. Router ID is quad 5, and then interface. Okay, interface ETH00 IP. Here we should use OSPFv3.1 IPv6 area 0.0.0.2. That's it. This is the configuration of the router 5. Let me to copy it to the CLI of router 5. Okay, now we can use the verification commands of the OSPF for example, neighborship, LSTB, and other information that useful for us for verifying the functionality of the OSPF v3. Now let me to use this OSPF version 3 verification command. You can use show OSPF IPv6 interface, okay, for verifying the interface enabled with the OSPF. Show OSPF IPv6 neighbor for the neighborship table, show OSPF v3 IPv6 database for the LSTB, and also show IPv6 route, and also with the OSPF keyword for the routing table. This is exactly similar with the OSPF version 2, only instead of show IP OSPF, we are using show OSPF v3 IPv6 or IPv4. Let me to show you. This is so simple. Starting from the router 1, this is router 1, we can use show OSPF v3, okay, IPv6, then interface. Here we have this information. You know that in most cases we don't use the interface information, all of the interface information. Because of that, it is recommended to using some keywords such as the brief. Show OSPF IPv6 interface or show OSPF v3 IPv6 interface brief. Here, as you can see, interface ETH00 is the member of process 1 and also area 1, address family or AF. AF is the abbreviation of the address family, okay, because maybe we are routing the IPv4. Here, address family or AF include the IPv6 routing, and the cost is 10. Cost exactly is same with the OSPF v2. Look at here, the cost equal to the 10 to the power of 8, okay, divided on the interface bandwidth. And because here the interface bandwidth is 10 megabits per second, because it is Ethernet, the cost is 10. The status is DR. We have exactly same functionality like the OSPF version 2 about the DR and BDR. And here, as you can see, the R1 is the R1 interface is the DR. We have one neighborship, one full neighborship. This is the state of neighborship, and also the total number of neighborships is 1. Exactly same function. Don't worry about the, for example, any difference. Here we don't have any difference. After that, this is the router 1. Okay, let me to show you the result of this command also in the router 2. Show OSPF v3 IPv6 interface brief. Look at here, ETH00, ETH01. ETH00 and ETH01, both of them are members of the process 1, but ETH01 is residing on the area quad 0. ETH00 is residing on the area 0001. Both of them are, for example, routing IPv6, and here the cost the cost of each interface is 10. The state of ETH01 is DR, because here we have DR BDR, here also we have a DR BDR, and also we have one neighbor. In the router 3, let me to show you the router 3. Show OSPF v3 IPv6 interface, okay, or interface brief. As you can see, here we have ETH00 and ETH01. Both of them are members of the ETH of the area 0. And then in router 4, show OSPF v3, okay, IPv6, for example, interface brief. As you can see, ETH00 is member of area quad 0. ETH01 is member of area 0.0.0.2, and both of them are working under the process 1. That's it. After that, about the router 5, the last router, show OSPF v3, okay, show OSPF v3 IPv6 interface brief. Okay, ETH00, process ID is 1, area is 2, and this family IPv6, cost is 10. That's it. Now, starting from router 1 for the neighborship table, show OSPF, okay, show OSPF v3 neighbor. like the IPv4, we are using show OSPFv3, but here we should use IPv6 neighbor because we want to see only the IPv6 neighbor. If you use show OSPFv3 neighbor, means both IPv4 neighbor and IPv6, but we are using the show OSPFv3 IPv6 neighbor. As you can see, we have one neighbor. Neighbor is quad 2. The priority of neighbor is 1, the default priority is 1. This is OSPFv3 neighborship table in process 1 for address family of IPv6 and router ID is quad 1. A state of the neighborship is full and our neighbor is BDR. Okay, dead time exactly has the same functionality of the dead time in the IPv4 with the same value. The default dead time value is 40 seconds. The default hello interval value is the 10 seconds. But here, instead of the interface IP, like the IPv4, we have interface ID. Interface ID is a unique identifier for one interface. I will talk about the interface ID, but as you can see now about the, for example, on the router 2, ETH00 has the interface ID of 3. Here in show IP OSPF neighbor, in the interface, in this field, we see the interface IP, for example, 10122. Okay, but here we see interface ID. I will talk about that, don't worry. After that, over the interface ETH00 of R1, we have neighborship. That's it. Let me to show you the neighborship table in the router 2. Show OSPF v3, okay, show OSPFv3 IPv6 neighbor. In router 2 we have two neighbor. First is router 1, second is router 3. Both of this interface of router 1 and router 3 are using the priority of 1, and the state is full for both of them. And here you can see the state or status of the neighbor, dead time, also interface ID, and also interface ETH00. We have over the interface ETH00 one neighborship with router 1, and over the ETH01 one neighborship with the router 3. It is the same. And then show IPv6 OSPF interface or neighbor. Okay, show IPv6, show OSPFv3. Look at here, show OSPFv3 for IPv6 neighbor in router 3. We have two neighbor, router 2 and router 4. And finally in the router 4, show OSPFv3, for example, neighbor or IPv6 neighbor. The neighbor is router 3 and router 5. And finally in the router 5, show OSPFv3 IPv6 neighbor. Again, the neighbor is the, for example, router 4. So easy. Okay. After that, we can use show OSPFv3 IPv6 database for verifying the LSTB. Again, about the LSTB, we have some similarities and also some differences. I will talk about them. But now only we are viewing the LSTB of different routers. Starting from the router 1, here, show OSPFv3, for example, IPv6 database can show us this is our LSTB in the router 1. Look at here. We have two LSA type 1, router link state. The concept of router link state is available in the, for example, in the OSPFv3. We have one LSA type 2, it is okay. We have three LSA type 3, we call it inter area. Instead of the summary, we call it inter area. 1, 2, 3, we have three network outside of area 1, and this is obvious that we should have three LSA type 3 here. Also we have LSA type 8, this is new, and LSA type 9, again this is new. Okay, you will learn about them, and it is so easy, don't worry. But here, as you can see, we have some differences in the internal logic of the OSPF version 3, include the LSA types. Okay, in the router 1, this is the database. In the router 2, this is ABR. Show OSPFv3 database or IPv6 database. Okay, it can show us here. Now we have two parts. The first part is for area 0, okay, and the second part is for area 1. About the area 0, this area, we have three LSA type A, for example, 1, and two LSA type 2, and also two LSA type 3. It is okay. Until now, this is exactly the same with the, for example, IPv4. OSPF or OSPF version 2, and also here we have two LSA type 8, we will learn it, and after that two LSA type 9, again we will learn it. Here you can see the LSAs of the area 1, two LSA type 1, one LSA type 2, three LSA type 3, 2 LSA type 8 and 1 LSA type 9. All of them are so easy. Don't worry, you will learn about them. This is the steps of R2 and then R3. Show OSPFv3, okay, and then IPv6 database. Here you can see we have 3 LSA type 1, it's okay because we have 3 router. We have 2 LSA type 2, it is okay because we have 2 multi-access link or DRBDR link. And after that we have 2 LSA type 3, it is okay because we have 2 network outside of the area 0. But here, as you can see, we have 4 LSA type 8, we will learn about it. And also we have 2 LSA type 9, again we will learn about them. In the router 5, this is another ABR. Show OSPFv3 IPv6 database. Can show us that we have in the area quad 0, exactly same like the router 3, we have 3 LSA type, for example, 1, 2 LSA type 2, 2 LSA type 3, okay, also 2 LSA type 8, 2 LSA type 9, and now about the area 2, we have 2 LSA type 1, 1 LSA type 2, 3 LSA type 3, okay, 2 LSA type 8 and 1 LSA type 9. You will learn about them, again, don't worry. And finally, in the router 5, show OSPFv3 database or IPv6 database. Okay, it can show us that we have 2 LSA type 1 because we have 2 routers, 1 LSA type 2 because we have 1 multi-access link or 1 DRBDR link, and we have 3 LSA type 3 because on the other areas we have 3 networks, and also we have 2 LSA type 8 and 1 LSA type 9. You will learn about the differences between the LSAs of the OSPF version 2 and OSPF version 3. Because of that, now we can understand a little the LSTB of OSPF version 3, but we will learn more than this about this LSTB. And finally, the next command is the show IPv6 route. Let me to start with the router 1, okay, but before talking about the show IPv6 route, let me to say that in the OSPFv2, okay, means OSPF for IPv4, we are using the code of the O for intra area routes, okay, and also we are using the code OIA, let me write here, OIA for the inter area routes, okay, and after that we are using the OE2 and also OE1, okay, for the external routes, the routes that we are learning from the LSA type 5, and also we have ON2 and also ON1, okay, for the NSSA external routes, okay. You have learned about them. In the OSPFv3, okay, we have similar codes, but with a little difference. For the intra area, we are using the code O for intra area routes. For inter area routes, we are using the code OI. Okay, this is connected to the O. And then about the external routes, we are using OE2 and OE1. About the NSSA external, ON2 and ON1. The concepts are same, but because of the saving the space, we are using the OE2 instead of the O space E2. That's it. This is the differences. Let me to show you. In the router 1, this is the router 1 routing table. I want to show you the routing table, include the route that we have learned from the OSPF. Show IPv6 route OSPF. As you can see here, we have this information. OI means inter area, as I mentioned before. Let me to show you. O means OSPF intra area. OI means OSPF inter area. OE1 means OSPF external with metric type 1, OE2 OSPF external with metric type 2, ON1 means OSPF NSSA external metric type 1, and ON2 OSPF NSSA external with metric type 2, okay? Here we have this information. The network 2001 DBA 23/64 means this network, okay? Available from the OSPF. As you can see, the administrative distance of OSPFv3 for all OSPFv3 route types is 110, exactly the same as the IPv4 or OSPFv2, okay? And the metric is 20. Why the metric is 20? Because the cost of this interface ETA00 is 10 and the cost of ETA01 of the router 2 is 10, because because of that, totally we have the metric of 20. And the next stop, as you can see, is using, for the next stop, we are using the link local address of the next hop interface, not the global address. I will talk about this a little more, but also we are using ETH00 to reach into this network. It is okay. About the next network, 2001 DB834 double colon SI64, this network, we are using OSPF with the administrative distance of 110 and with the metric of 30. As you can see, 10 plus 10 plus 10. And this is the next stop, the ETH00 of router 2 link local address. And then finally, for 2001 DB845 double colon SI64 for this network, we are using the, for example, ETH00 again, and the metric is 40. 10 plus 10 plus 10 plus 10 equal to the 40. So easy. All of them are inter-area routes. Let me to show you the routing table of router 2 for the OSPF route. Show IPv6 route, okay? Show IPv6 route, then OSPF. Here we have one intra-area route and one inter-area route. First, 2001 DB834 double colon SI64, this network is intra-network. The cost is 20. 10 plus 10 equal to 20. And then 2001 DB845 double colon SI64, this network, we have the metric of 30 to this network, 10 plus 10 plus 10, and this is the inter-area route. After that, let me to show you the router 3's routing table. Show IPv6 route OSPF. Here we have 2001 DB812 double colon SI64, this network with the cost of 20, 10 plus 10 equal 20, and 2001 DB845 double colon SI64, again we as the OI route, means OSPF inter area route with the cost of 20. It is so easy. After that, the router 4, show IP, for example, show IPv6 route, okay, OSPF. We have 2001 DB812 double colon SI64, this network, and this is the inter-area route with the cost of 30. 10 plus 10 plus 10 equal 30. And then 2001 DB823 double colon SI64 with the cost of 20. 10 plus 10. So easy. And finally, the router 5. Show IPv6 route OSPF. We have 3 network, 2001 DB812 double colon SI64 with the metric of 40, this network, 10 plus 10 plus 10 plus 10 equal to 40. Then 2001 DB823 double colon SI64, this network, 10 plus 10 plus 10 equal 30. And then 2001 DB834 double colon SI64, this network, the metric is 20. It is so easy. But let me to say that it is recommended for easier understanding and easier working with the routing table. We are configuring the link local address with simpler, for example, IPv6 address. Let me to show you. For example, in the R1, for this interface ETH00, I'm going to use this command, interface ETH00 IPv6 address FE80 double colon 1 link local. Now the interface, the link local address of this interface changed to the FE80 double colon 1 link local. Also in the router 2, we can use this command, interface range ETH00 to 1 IPv6 address FE80 double colon 2 link local. You know that we can configure same link local address on multiple interface of a router. The neighborship is resetting. After that, in router 3, conft interface again range ETH00 to 01 IPv6 address FE80 double colon 3 again link local. And finally, in the router 4, conft interface for example range ETH00 to 1, okay, IPv6 address FE80 double colon 40 link local. And we have also another router 5, conft interface ETH00 IP, okay, v6 address FE80 double colon 5 link local. Now let me to show you the result of our configuration in the routing table. Look at here, it is so simpler. Show IPv6 route OSPF in router 1. As you can see, the next hop is FE80 double colon 2. It is easier to understand in compare the previous next hop that we had before. Look at here. After that, About the router 2, also in LSTB we have simpler work for the, for example, with these link local addresses. Show IPv6 OSPF or show IPv6 root OSPF. Look at here. In R2 we are using to next stop FE80:3, okay, and then in the router 3 show IPv6 or a root, okay. OSPF can show us we have two next stop FE80:2, okay, and also FE80:4. As you can see, it is so easy. And then in router 4 show IPv6 root OSPF. The next stop is FE80:3. Because of that, it is recommended to configuring the link local addresses with a simpler for example convention. After that, if you want, you can use show IPv6 protocol. This is also useful for verification of the IPv6 routing protocol. Show IPv6 protocols. Okay, here in the router 1 I'm going to use this command, show IPv6 protocols. Here we have IPv6 routing protocol of OSPF1, router ID is quad 1, number of areas is 1, and this is normal area. Here we don't have any stub area and NSSA area. Let me to say that in OSPFv3 the concept of area types exactly is same with the OSPFv2. Okay, because of that now you know about the normal area, stub area, totally stub area, NSSA area, and also totally NSSA area. Then interfaces area, we have one interface ETH00, this is working on the area 0.0.0.1. After that, in the router 2 show IPv6 protocol can show us that we have a routing protocol of the IPv6 as OSPF1, router ID is quad 2, this is area border router or ABR, and the number of areas in this router is 2, both of them are normal area. And then here we can see that the interface ETH01 is working on the area 0 and interface ETH00 is working on the area 1. We don't have redistribution. Also in the router 3 show IPv6 protocols. As you can see, the IPv6 routing protocol is OSPF1, router ID is quad 3, number of areas in this router is 1, okay, and that is normal area. Both interface ETH00 and ETH01 are working under the area quad 0. And after that, about the router 4, show IPv6 protocols. Show IPv6 protocols can show us that we have the routing protocol as OSPF1, router ID is quad 4. This is area border router. And after that, we have two normal area, no stub area, no NSSA area. And then interfaces ETH00 is working under the area quad 0, and interface ETH01 is working on the area 0.0.0.2. Okay, finally router 5 show IPv6 for example protocols. We have the routing protocol as OSPF1, router ID is quad 5, number of areas is 1 normal area, and we have one interface on the area 2. Don't forget, here again we have the same concepts. R1 is the internal router, R5 also is internal router, and R3 is internal router, and R2 and R4 both of them are area border router or ABR with the same concepts. And also the R2, R3 and R4, all of them are backbone routers. Also in OSPF we have the concept of the ASBR or autonomous system boundary router. You know that when we are connecting the OSPF network to other networks, okay, and we are redistributing from other networks to the OSPF network, the name of the router that we are redistributing, we are doing the redistributing command on that router is the ASBR or autonomous system boundary router. You know that in OSPF version 2 we have multiple type of packets. For example, in OSPF version 2 we have hello, database description, link state request, link state update, and also link state acknowledgement. Let me to say that in OSPF v3 we have exactly the same packet type. For example, we have hello packet. We are using hello packet for discovering and also maintaining the neighborship. We have database description. We are using database description to, for example, summarizing the database content with a sequence number and some other things that you have learned before. In link state request, we are requesting some database information. In link state update, we are sending database update, or for example, we are sending the link states to other routers. With link state acknowledgement, we are, for example, sending acknowledgement to the when we are receiving, for example, link state update. Everything is same. about the OSPFv3 packet type: hello, database description, link state request, link state update, and also link state acknowledgement. But let me to say that you know that in OSPFv2 we are sending the hello packets, okay, OSPFv2 hello packets to one multicast IPv4 address reserved for the OSPF, and the OSPFv2, okay, multicast address is the 224.0.0.5. okay. Again, we have exactly the same concept in the OSPFv3. Actually, in OSPFv3 we are using this multicast address. You know that in IPv6 all of the multicast address should start with the double F or FF02:5. As you can see, the scope of this address is inside one segment, okay, or one subnet, FF02:5. Also in OSPFv2 we are using another reserved multicast address for the DR and also BDR, and that IPv4 address is the for example 224.0.0.6. okay. Exactly, we have this concept on the OSPFv3, and the IPv6 address of the DR and BDR, okay, is the FF02:6. That's it, okay. As you can see here, we have some similarities between two multicast IPv4 address and also multicast IPv6 address. Let me to show you here. You can capture one of these links if you want. For example, in R1, let me to capture ETH00. We can see the OSPFv3 hello packet here. Let me to show you. And after that, I will talk about the passive interface. Look at here. Here we have OSPFv3 packets, OSPF. As you can see, we are sending OSPFv3 hello packet from the source IP of the link local address to the destination address of FF02:5, okay. And also for DR and BDR we are using FF02:6. Let me to show you the IP addressing that we have on the router 1. On router 1 on ETH00, show IPv6 interface ETH00, we have these two multicast address, FF02:5 and FF02:6. The reason is that here on this interface we have the role of DR and BDR. Look at here, show IPv6 or show OSPFv3, okay. Then IPv6 interface ETH00 can show us that OSPFv3, not OSPFv6, can show us that this is the DR. DR has the IP address IPv6 address of FF02:6 also. Show OSPFv3 interface. For example, here we should use show IPv6 interface. Show IPv6 interface ETH00. As you can see, we have these two IPv6 address on the router 1 because this is DR. Also, and you know that for the hello interval and dead interval, we have the same values in the OSPFv3. Show OSPFv3, okay, interface for IPv6 interface ETH00. We have the same values. Hello time is 10 seconds by default, and dead time is 40 seconds, and everything is same about the hello time and or hello interval and dead time in the, for example, OSPFv3 in compared with the OSPFv2. But again, here we have the concept of DR and BDR. Assume that R1 connected to one LAN interface. Let me to show you. I want to configure the passive interface in this scenario. Let me to add one switch to the router 1 and also another switch to the router 5. As you can see now, we have one switch here connected to the router 1 and another switch to the router 5. Let me to configure this interface on the router 1, EN conft interface ETH01. The IPv6 address of this interface is the 2001 DB801:1/64, and then for example no shutdown. That's it. And also on the router 5, let me to configure the new interface, conft interface ETH for example 01. After that, IPv6 address 2001 DB8 05:5/64, and then no shutdown. Okay, and after that, let me to enable OSPF on these two interface. On the router 1, OSPFv3 1 IPv6 area 0.0.0.1, and also on the router 5 again OSPFv3 1 IPv6 area 0.0.0.2. You know that now we have communication between we have connectivity between these two LAN. Let me to show you. From R1 we can use ping command to the 2001 DB8. Okay, then 0 dot column 5 double column 5, this is the ETH01 IP address with the source of for example Ethernet 01. That's it. Look at here, we have connectivity without any problem. Okay, now you know that R1 is sending hello packets or OSPF hello packets on the ETH01, and also R5 is sending hello packet on the ETH01, but you know that here we don't have on their LAN of router 1 and on the LAN of router 5 we don't have any neighbor, and we don't expect to find any neighbor. Because of that, sending the hello packets can consume the resources such as the bandwidth, such as the CPU of the router 1. Because of that, we are trying to prevent the sending of the for example hello packet, but we don't want to remove OSPF from this interface. You can easily configure the passive interface, exactly the same concept and same configuration like the OSPF version 2. If you want to configure one interface as the passive interface, okay, you can configure this feature with two methods. The first method is configuring router config router, the passive interface, okay, and after that the interface name. For example, we have multiple passive interface, we should configure multiple passive interface command. The next command, the next method is using the passive interface default, passive interface, after that default, and also on non-passive interface we can configure no passive interface, after that interface name. For example, in the router 1, let me to show you how we can configure the ETH01 as the passive interface. Let me to show you here on the show OSPF, okay, show OSPFv3, after that IPv6 interface ETH01, we can see that now we are sending for example hello packets in each 10 seconds, as you can see. Okay, and after that, let me to configure the ETH01 as the passive interface, router OSPFv3 1. Okay, here we should use router OSPFv3, okay, process 1, then passive interface ETH01. That's it. So easy. Look at here, show OSPFv3 IPv6 interface ETH01 can show us that now we don't send hello. We can, with this command you can easily find the passive interfaces. Here you can see the passive interface, or if you want you can use show OSPFv3 interface ETH for example 01, then include passive. Okay, include the passive keyword. As you can see, we have no hellos and passive interface. That's it. The next method in the router 5, let me to configure the router 5 with the next method, router OSPFv3, okay, then 1. Here we can use passive interface default. Now all interfaces are passive, we don't have any neighborship. After that, no passive interface, ETH01, again ETH00, we should configure no passive interface for the ETH00, no passive interface, ETH00. After that, show, now we have neighborship, show OSPFv3 IPv6 neighbor can show us that we have neighborship. Also show OSPFv3 IPv6 interface ETH00, okay, can show us that this interface is not passive, but ETH01 is passive. So easy. Because of that, the concept of passive is available in the OSPFv3 with exactly same concept, okay, same configuration also in the OSPF version 3. Let me to talk about the next topic. The next topic is the network type. You know that in previous version of OSPF version 2, okay, we have learned about the network type. You know that in OSPF version 2 we had point-to-point network type, point-to-multipoint, and also broadcast, non-broadcast, and I have explained all of them in one scenario. Here I'm going to show you that everything is same about the network type, okay? But in some cases, we are changing the network type. For changing the network type, we have a similar command that you have used before, but with a little difference. Let me write here, network type. You know that in OSPF version 2, we are using IP OSPF network command on the interface. Here we are using another command. Look at here, router config if for changing the network type. OSPFv3, okay, instead of the IP OSPF. Then network, after that you can configure a point to point. Then, for example, point to multi-point, point to multi-point. After that, the next option is broadcast. After that, the next option is, for example, non-broadcast. That's it. Let me to show you. It is so easy. With the show OSPF IP, show OSPFv3, IPv6, for example, interface, you can verify the network type. In the router one, let me to show you, this is the router one, and here we can see show OSPF. This is router one, okay? Show OSPFv3 IPv6 interface ETH00. Look at here. As you can see, the network type of this interface, okay, you know that the ETH00 is the, for example, Ethernet interface. And by default on the Ethernet interface, we are using the network type of broadcast. This means that on this interface, we will have DR and BDR, and other concepts are same with the OSPF version 2, okay? Also in the router 2, we have the same state, okay, the same network type. Show OSPFv3 IPv6 interface ETH00. As you can see here, the network type is broadcast. You know that when we are using one Ethernet link between 2-point router R1 and router 2 R2, it is recommended to configuring the, for example, network type to the point-to-point, as I have explained before. Let me to configure the ETH00 and ETH000 of R1 and R2 with the network type of point-to-point. Conft interface ETH00 OSPFv3 network. Look at here, we have this option now. Broadcast, non-broadcast, point to multipoint, and point to point. Let me to configure point to point, that's it. And also in the router 2, let me to configure the same network type, interface ETH00, OSPFv3, then IPv6, okay. After that, for example, OSPFv3 network, not IPv6. And after that, point to point. That's it. Now we have neighborship without any DR and BDR. In the router 1, show OSPFv3 IPv6 interface ETH00 can show us now this interface is using the state of point to point, and as you can see, we don't have any, for example, DR and BDR on this interface. Show OSPFv3 IPv6 neighbor can show us that we have full neighborship without any DR and BDR election. Also, in the router 2, we have similar conditions. Show OSPFv3 IPv6, okay, interface ETH00. It can show us on this interface we are using the network type of point to point, but for ETH01, if you check, you can see that the network type is broadcast. And you have learned about the detail of this network type in previous videos, and you know that everything is same, only then we should configure the network type with different command. Also, another recommendation about the changing of network type related to the loopback interface. Assume that here we have one loopback interface. Let me to configure one loopback interface for remembering the for example, the examples that I had explained before. For example, on the router 1, we have this loopback interface, loopback 0. The IP address of this loopback is 2001, okay, db8. Then double column 1, okay, /128. This is the loopback IP address of the R1. And but I'm going to configure the loopback IP address with the /64, not /128. Let me to configure it in the router 1. Conft interface loopback 0, then IPv6 address 2001 db8, okay, double column 1 /64, and then no, for example, OSPFv3 1 IPv6 area 0.0.0.1. You know that when we are advertising the loopback in IPv4, okay, in OSPF version 2, we should advertise the loopback because of its network type with the /32. In the IPv6, we are advertising the loopback with the prefix length of 128. Look at here. Let me to show you the loopback network type. Show OSPFv3 IPv6 interface loopback 0. Okay, and here we have the network type of loopback. After that, loopback interface is treated as a stop host, means this is for example, IPv6 address of this loopback, assuming 2001 db8:1/128. Let me to show you the routing table of router 5. In the routing table of router 5, show IPv6 route OSPF, we can see that we have one loopback interface. And as you can see, the prefix length is 128, but you know that the prefix length that we have configured is /64. We can correct it by changing the network type of the loopback interface of R1. conf-t, okay, interface loopback 0, OSPFv3, then network. So easy, point to point, that's it. Okay, and after that, in the router 5, you will see a /64 for the loopback interface, as you can see here. Also in the router 1, let me to show OSPFv3 IPv6 interface loopback 0. Let me to say that in most cases we don't change the network type, only in some rarely cases. For example, when we have one Ethernet link between 2 points, we are changing the network type to the point, and in some cases that you configured the loopback with the mask other than the /128, maybe we need to change the network type of this loopback to the point to point. But in most cases, we don't change the network type in OSPFv2 and also in the OSPFv3. The next feature that we can talk about that is the summarization. You know that we can summarize the routes in the OSPF version 2 on the ABR and also on the ASBR. Here we have exactly the same functionality. You can configure summarization on the ABR. Okay, you know that inside of the area in OSPF version 2, we don't have the option of summarization. Also in the OSPFv3, because of the same reasons, we can configure summarization on the ABR and also ASBR. Let me to show you. For example, here we have one loopback 0 with this IP address. Now we can configure another IPv6 address, another loopback interface for summarization. For example, 2001 db8:1/128 is the IP address of the loopback 0. Loopback 1 has 2001 db8:2/128, and for example, loopback 2 2001 db8:3/128. Let me first configure these three loopback 0, 1, and 2, and then we can talk about the summarization. In the R1, no interface loopback 0. Okay, again, I'm going to configure the loopback 0. Interface loopback 0, IPv6 address 2001 db8. This is for loopback 0. Then :1/128. That's it. Interface loopback 1, IPv6 address 2001 db8. After that, :2/128. And finally, interface loopback 2, IPv6 address 2001 db8 :3/128. Okay, and then on the interface loopback 0, I'm going to configure OSPFv3 1 IPv6 area, for example 0.0.0.1. Then interface loopback 1 with the same command, and then interface loopback 2 with the same command. Okay, on the router 2, let me to find these networks inside the routing table of router 2. Show IPv6 route OSPF. As you can see, now until now we have learned 2001 the db8:1/128. Okay, after that, let me to show you, now we have all of these three routes. And also in the other routers, for example, router 3, router 4, router 5, we are learning about them with the 3 link state type 3. Look at here in the router 3. Let me to show you. Show IPv6 route OSPF. As you can see here, we have 3/128 summary route, and also in other routers like the router 4. This is the router 4. Show IPv6 route okay, OSPF, we have all of these subnets. Now I'm going to talk about the summarization. The summarization command exactly is same with the summarization command in the, for example, OSPFv2. You know that in ABR, we are summarizing LSA type 3, okay? And because of that, we should use area range command. That's it. Look at here, summarize ABR, then summarization. You know that in IPv4 we have used area ID range, summary IP, summary mask, and here exactly we are using the same command. Router config router. Look at here, area ID range. The area is the area that we are subnetting. We are summarizing the subnets of that area, and then range here we should use summary prefix, okay, or summary IPv6 prefix, summary prefix. For example, length. Let me to show you. It is so easy. In the router 2, okay, in the router 2, we are going to the router OSPFv3, okay, router OSPFv3, and then process ID 1. Here we should use area command, area, then 0.0.0.1 range means please summarize this area, okay, to which IP address, to the for example summary IP. Here also we have one important notation, and that is for summarization we should go first to the address family. After that we can do this command. Let me to show you. First we should go to the address family, for example address family IPv6 unicast mode, and then router config router AF means address family, and now we can use this command. Let me to show you. This is so simple. Here we can use address family IPv6 unicast, then area 0.0.0.1 range to which IP, to this IP 2001 db8. For example, double con. Look at here. You know that until the last hex state we have everything same. We can configure 2001 colon db8 double colon /112 because we have 16 bits in the last hex set. If you want, you can use more exclusive summary, but this is okay. And after that here we have this mask, okay, and let me to add here one slash, and after the summary length. That's it. Look at here, this is our command. Also here we have the options that we had before in the summarization in IPv4. Advertise is the default, not advertise is the filtering command, and cost is the, if you want you can configure the cost. Here also we have one difference. In IPv4 when we are advertising the summary and mask, the summary metric is the best metric on the subnets, but in the IPv6 we are using the reverse function. Actually the worst metric is the metric of the summary, but this is not so important. Look at here in the R2 when you are using this command. In the router 3 now we will have one summary, show IPv6 route OSPF. This is our summary, and the cost of summary is 20. Why? Because here we have the cost of 10, okay, and in the router 2, let me to show you, do show IPv6 route OSPF. It can show us the cost of router 2 to these loopback interfaces, to all of this loopback interface are 10, and because all of them has the cost of 10, the cost of summary also is 10. This is the discard route or summary route. You have learned about it, and because of that we are sending the LSA type 3 with the cost of 10, and we have between the router 3 and router 2 one Ethernet interface, one Ethernet link. The total cost is 20, as you can see here. We are receiving in the router 2 this summary, in the router 3 this summary route. Look at here, this is our summary. Also in the router 4 show IPv6 route OSPF can show us we are receiving the summary with the cost of 30. 10 plus 10 plus the summary metric is equal to the 10. Everything is same, but here, as I mentioned before, we have one difference. The difference is that the metric of summary is for example, worst metric between the subnets metric, but in the IPv4 in OSPFv2 we are using the best metric. After that, you know that you can configure the cost. It is recommended. Here in the router 2, we can use area 0.0.1, okay, 0.0.0.1 range to this range, and after that with the cost of, for example, 50. Okay, in the router 3, if you check now, after some second, you can see that the cost will be 60. 50 plus 10 equal to the 60. In the router 470, as you can see. Okay, this is the summarization on the ABR. You know that here we didn't experience any the difference between the IPv4 and also IPv6, means between OSPFv2 and OSPFv3. Another interesting function related to the OSPFv3 is that we don't need necessarily configuring the, for example, interfaces between the router 1 and router 2, router 2 and router 3 with the global unicast address. You know that because the neighborship, the advertisement of the DBD, LSR, LSU, all of them, or also LSAC, are doing, okay, are occurring with the link local address. Because of that, one of the benefits of the IPv6 is that we can, for example, we can remove the global unicast addressing from the link between the router 1, router 2, router 2 and router 3. This is so simple. You can only use IPv6 enable on one interface for enabling link local address on that interface. Let me to show you. On the R1, this is the configuration of the R1 do show run interface, okay, ETH00. We have configured before this command IPv6 address, for example, link local and also IPv6 address, this address. Yes, here we have link local address, but if you don't have link local address, with the IPv6 enable, you can easily enable the link local address on this interface. Let me to remove these two commands because this is not mandatory. We don't have now configured link local, and we don't have now the global unicast address. Okay, in the router 2 also, let me to remove both of them. Do show run interface ETH00. Here, no, let me to remove both of them. This command first, okay, and also the next command. Let me to show you on the interface ETH00. We can remove both of this command. No, the first command, and then no, the second command. As you can see now, we don't have any IPv6 address on the router 2's interface, also on the router 1 interface. Let me to check. Do show IPv6 interface brief. On the ETH00, okay, we have removed the, for example, on the ETH00 and ETH01 we have IP address. Let me to go to the interface ETH00 and using this command do show run interface, okay, do show run interface ETH00, then no. After that, no IPv6 this IP address, and then no IPv6 for the next IP. Now we don't have any IPv6 address between the router 1 and router 2. Let me to show you. Show IPv6 interface, okay, brief. On the router 1, as you can see, on the ETH00, we don't have any IPv6 address. Let me to configure only one simple command. Interface ETH00, okay, IPv6 enable. That's it. And then in the router 2, do show IPv6 interface brief. Over the ETH00, we don't have any IP address. Okay, let me to configure interface ETH00, then IPv6 enable. Now we have one link local, one dynamically generated link local on these two interface. Let me to show you on the R1. Do show run interface ETH00. We have only one command, IPv6 enable. Okay, and here do show IPv6 interface ETH00 can show us that I do show IPv6 interface brief is better command. As you can see, we have link local address on the ETH00. Now it is sufficient to configuring the OSPFv3 on this interface. Interface ETH00 OSPFv3 IPv6 area 0.0.0.1. That's it. In the router 2 also, interface ETH00 OSPFv3 IPv6 area 0.0.0.1. This means that we can, for example, don't configure the IPv6 address between the router 1 and router 2, router 1 and router 2 and router 3. It is so simple. You can configure only the LAN interfaces that you have you need to connectivity to have connectivity between them. In the router 1 now, let me to send traffic to the, for example, router 5, ping 2001 db8, then 0, then 5 :5. As you can see, we have connectivity. Also, show OSPFv3 IPv6 neighbors. can show us we have neighborship with the quad 2, the router 2. This is the router ID of the router 2. Everything is working. This is one of the benefits of the IPv6, that you can use it for easier and also faster configuration of the, for example, different routing protocols such as the OSPFv3. Alright, in this video we have learned about the OSPFv3 fundamentals and also basic configuration, basic verification command, and also some features like the summarization, like the passive interface, like the, for example, hello interval and dead interval, and some other things. Actually, now you can implement OSPF version 3 in your networks. You can easily implement it because many of the features of the OSPF version 3, as you saw, are same with the OSPF version 2. But in the next video, I'm going to talk about some of the differences. For example, I will talk about the differences about the link states in the OSPFv3 with OSPFv2. I will talk about the differences about the authentication, for example, and some other things. You will learn about them. In this video, we have reviewed more than the differences about the similarities between the OSPF version 2 and OSPF version 3. It's your turn. You need to configure to think about the OSPFv3, and also after that you should verify everything with these commands, and finally you will be ready for learning about the OSPFv3's differences with OSPFv2, some a little more complex features such as the differences between the LSAs. It is recommended to reviewing the LSA of the OSPF version 2. After that, please come with me to the next video. We will talk about again OSPF version 3, but related to the differences between the OSPF version 2 and OSPF version 3. At the first topic, we will talk about the link states or link state advertisement in OSPF version 3. For example, you will learn about the LSA type 8 and LSA type 9.